Recording in progress.
All right, so this video will cover the very last section of chapter 5. So we're going to go over some more inequalities. And then the next quiz will cover actually 5.5 and 5.4, which we've already done. All right, so we go ahead and start with the fact that for line segments to create a triangle, they have to be within a certain range of lengths compared to each other. So in the first one, you can see that you can make a triangle shape with a side that is 9 centimeters, 6 centimeters, and 5 centimeters. So fill in the yes, then we'll go back and look at these. So for the second one, if you have 9, 6, and 2 as the side lengths, they're never, at no point is the 6 centimeter and the 2 centimeter going to meet in a way that creates a vertex. Even if it goes all the way down, this one's going to go down and intersect 9 centimeter length here. There's always going to be a space between the two. So one is too short in order for them to meet. So this does not make a triangle. And then for the last one, if you have a side that's 9 centimeters and then you have one that's 5 and one that's 4, those are going to meet. Unfortunately, they meet on the same line as the 9 centimeters. So it can create collinear points. However, it will never create a triangle because there's no angle measurements. They would all be 0. So those will lead into the relationship of the sides of a triangle. In this case, you want to always look and see, is one side always less than the sum of the other two? So 9 is less than 11, therefore it does make a triangle. For this one, 9, 6 plus 2 is 8. 9 is not less than 8, so it cannot make a triangle. They do not meet. And then 9 is not less than 5 plus 4. In fact, it's equal to. So anytime one side is equal to the sum of the other two, you actually end up with all collinear points. They're going to only exist on the same line.
Recording in progress.
9 compared to 5 plus 4, which is 9. So not less than, but it is equal to, again. So that's why we have those collinear points. Resetting. All right, this leads to our inequality theorem. The triangle inequality theorem says that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So if you have a triangle, there we go, ABC, then AB, AB must be less than BC plus AC, and then that goes for each individual side. So let's look at an example. So if two sides of a triangle have the lengths of 4.7 centimeters and 6.8 centimeters, find the range of possible lengths for the third side. So in this case, I'm always going to want to draw my triangle. So I'll say this is 4, 7, 6.8. All right, and then my unknown side is x. So first I can find the maximum that side length can be. So it has to be less than 6.8 plus 4.7. So this means that that side length, the largest it can be is anything less than 11.5. Now to look at the other side, I'll take the longest side that they gave me, 6.8, must be less than x plus 4.7. So that way I subtract, sorry, I'm trying to just my finger here, it's so messy. Subtract 4.7 from both sides. And you end up with x must be greater than 2.1. So that creates the range of possible lengths. So that third side can be as short as 2.1, and they will still meet with some sort of angle measurement, even though it might be minuscule, and it can be as long as 11.5. But that creates the range that we're allowed to have for that third side in order for it to still create a triangle. This next one gives us more of a sort of an industry example. Let's see. Still can't get my pen to work. Oops. So in this example, we have a designer seeks to optimize kitchen efficiency by arranging the sink, refrigerator, and stove in a work triangle. The total distance between the three appliances cannot exceed 20 feet, with stove to refrigerator distance being the shortest. So explain whether each of the following sets of distances form an efficient work triangle. I'm going to move on to the next one because this has our table, and I think on y'all's it's a little bit harder to see. This is 5 feet, 7 feet, 6 feet. This one's 4 feet, 6 feet, and 10 feet. So this is option A, this is option B. So for option A, we have stove to refrigerator is 5. I'm going to use my image here. So it stops working. Refrigerator to sink is 7 and stove to sink is 6. So refrigerator to sink, this one is 7. This one is 6. All right, so looking at this, if I can minimize it.
Recording in progress.
So we have a couple of requirements. First, the distance between the three can't exceed 20 feet. So this is essentially the perimeter. So add all your sides up. 5 plus 7 plus 6 equals 18 feet. That is less than 20 feet, so that works. Second option is the shortest side from the refrigerator to the stove? And it is. So 5 feet is the shortest. So that works. The last thing we need to do is we need to check the, it does do these measurements actually create a triangle. So I'm going to start with my largest. Is 7 feet still less than 6 plus 5? And 7 is less than 11. So comparing my two shortest, they will still meet with the longest, so that works. So all of the qualifications are met for option A. Right. I'm gonna use the other image for B. So this one, we had what? 4, 6, and 10. Wait, that's the shortest refrigerator to sink. Okay, sorry. 4, 6, and sink to stove they had as 10. So for this one, again, the perimeter is equal to 10 plus 4 plus 6, which is 20 feet. So it still fits within the workspace. That's the first option. Second thing we needed to check is that the stove to fridge is 4 feet, which is the shortest. And then the third is we take the longest side and set it up is less than the other two sides added together. In this case, 10 is not less than 10, it's equal to. So this actually creates collinear points. So it does not meet the last requirement. So option B is not a valid work triangle. All right. Let's see. Okay, so let's move on. We have the hinge theorem. So the hinge theorem says that if two sides of one triangle are congruent to two sides of a second triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. So let me show you what I'm talking about. See if I can get it. Maybe to draw. Here it is. Okay, so we have two triangles here. And what they're saying is if two sides of one triangle are congruent, so if this side and this side are congruent, and this one and this one are congruent, but let's say this interior angle here is 30 degrees, and this interior angle is 45 degrees, then that means that the side opposite the 45 degree is longer than the side opposite the 30 degrees. This one would be the shorter of the two because the 30 degrees is less than 45. All right, the hinge theorem is sometimes called the side angle side inequality theorem because the side angle side inequality or side angle side congruence is used to prove the hinge theorem. The converse of the hinge theorem is sometimes called the side inequality because it describes the angles opposite sides of unequal length to the two pairs of sides that are congruent. Now we have that here. Again, converse, so if the hinge theorem says that the angle measurements show you which opposite side is larger, the converse says that which opposite side is larger shows you which interior angle. So it just means you're going in the opposite direction, but you're working with the same corresponding parts. So again, for this one, this is saying, here we go. If you have two triangles and two of the sides of one triangle are congruent to two of the sides of the other, and that this third one is longer in the first triangle and shorter in the second, then that means that the interior angle is also a larger measurement than the one with the shorter opposite side. I'm sorry, that's so messy. I'm having to use my fingertip instead of my pen. Okay, so that's the converse. So let's actually use these and practice it. In this trapezoid that we have that's made up of these two triangles, we need to compare the given measures. So they told us that Kn is congruent to Lm. We also know that NL is congruent to NL. So we have to look at which angle is included. Well, in the top left triangle, that's KNL is the included angle, and in the bottom right, NLM is the included angle between those congruent sides. So we compare KNL, then we have to look at the opposite sides measurement of both of these angles. So line segment KL is 5, and that is the opposite side to measure the angle KNL. And then MN is 7. That's the opposite side to angle NLM, or they call it MLN. So 5 is less than 7. So that means that the interior, that included angle, is going to be less than. KNL is going to be less than MLN. Hold on, let's look at this theorem. We use the sides, compared the opposite sides to prove the included angle. So this was the converse of the, I believe, right? Hinge theorem. Converse says that the side proves the angle. Yep, so this is the converse. Converse hinge theorem. This next one, they again have given us congruent sides, and they've given us a reflexive side. So we know that's congruent. So what they gave us is they gave us the included angles, which will tell us information about the opposite sides. So because angle UXV is larger than angle WXV, that means that its opposite side, UV, is also greater than the opposite side, VW. This is the hinge theorem. Okay, this last one is very similar to what we did before. And so it's just kind of a next step because we're working with variables. So again, you can see that we have two congruent sides in each triangle. And so the angle measurements that were given are our included angle. So that tells me, so I need to find the range of possible values for x. So I know that 100 degrees is greater than 70 degrees. So that means that its opposite side, 3x minus 1, has to be greater than 5 minus x. So now I can solve for x. I am going to add x to both sides. Let's see. So I end up with 4x minus 1 is greater than 5. Now I'm going to add this 1 to both sides, and I end up with 4x is greater than 6. I'm out of room. I'm just going to move this over here. All right, so 4x is greater than 6. We divide by 4, and of course that reduces, and x is greater than 3/2. So there's one end of my range. I have to look at the other one. So what I'm going to do is I'm going to take the smallest side, because I know the smallest side cannot be 0 because, and we have to be careful here because 5 minus 5 would make that side length 0, and it has to have some sort of measurement. So I'm going to take my smallest side, and that there is, obviously 5 is greater than 1.5. So that's where I'm going to find my end. But let's look at this. So I'm going to set up that side. Hold on. As 5 minus x has to be greater than 0. When I do that, I'm actually going to move the x, so it's positive, and I get 5 greater than 0. So what that tells me is that for my values of x, x has to be greater than 3/2 or 1.5, but it also has to be less than 5. So there's the range of the values that x can be and still give me a triangle with those two congruent sides. All right, and that's it. I'm going to make a separate video going through the homework and then a couple of the extra pieces, extra exercises from section 5.4, although what you have should be enough to help you with that quiz. But I will have one more video with a little bit more practice. Thank you so much.